fellow mathematicians. This is the final lesson of Unit 3 when we are solving two variable systems. You will be able to solve the system using the appropriate method and identify what type of solution it is. So the two types of solutions that we are adding today is a no solution, and that is when we are solving, all the variables cancel out, leaving us a false statement such as 0 equals 1, that's not true, that's false, or negative 2 equals 2, again, that is a false statement, not a true statement. So if you have no variables and the numerical statement is false, then your answer is no solution. Conversely, infinitely many solutions, when we are solving, all the variable terms cancel out, leaving us a true statement such as 0 equals 0, or 1 equals 1, or negative 2 equals negative 2. So notice that from our one variable equations, when we got to the special solutions, the all variable terms canceling out was part of the deal. And notice that here, all the variable terms canceling out is also part of the deal. So when you have no variables to solve for, you know it's going to be a special solution. Our directions don't tell us what method to use, but we need to rely on the information that we've learned from past lessons to decide what would be the best method. So as I look at number 1, that first equation is in standard form. The second equation is solved for y. So since we have an equation solved for y, the best method would be substitution, because we are going to substitute this into the other equation. So I have 5x minus big parentheses equals negative 2. What goes in the parentheses? Well, 5x minus 8 does. So I simplify, distribute that negative, so I have negative 5x plus 8 equals negative 2. So we still need to simplify. 5x minus 5x is 0, so that leaves us with 8 equals negative 2. My x is gone. That must mean I have a special solution. So is 8 equal to negative 2? Is that true or is that false? Well, that's false, because I would much rather have $8 than owe somebody $2. So that's a false statement, which means our solution, our answer is, there is no solution. So you need to say that. When we are solving and it is a special solution, this is what I'm looking for. I'm not looking for this. I mean, I'm sort of looking for that, but that's not the final answer. This is the final answer, okay? Do I need to see that a equals negative 2 at the end? Absolutely, but that is not where you stop. Let's take a look at example number 2. The first equation is in standard form, but the second equation is solved for y. So again, the method we should be using is substitution. And we are going to substitute into the y, not the x. Silly me. Negative 2x plus 2, big parentheses equals 2. And what goes in the parentheses? Well, what does y equal? Well, y equals x plus 1. Simplify and solve. Distribute. Combine like terms. Negative 2x plus 2x is 0, leaving us with 2 equals 2. I didn't even give you a chance to guess. So all of our variables canceled out. Is this a true statement or is this a false statement? Is 2 equal to 2? Absolutely. If you have $2 and I have $2, we have the same amount of money. So this is true, which means our solution, our answer, is infinitely many solutions. Again, this is what I'm looking for. Words. Let's look at example 3. Our first equation is in standard form. Our second equation is in standard form. So that means the easiest method to use would be elimination. So I need to check to see if there's anything I can multiply by. And looking at my smallest numbers, 3 can be multiplied to equal 6 by multiplying by 2. Since 6 is already negative and 3 is positive, I don't have to worry about the negatives. So distribute that, get 6x plus 2y equals 20. If you want to rewrite this down below, you certainly can. So the first equation would be negative 6x minus 2y equals negative 20. Combine your like terms, add 6 minus 6 is 0, 2 minus 2 is 0, 20 minus 20 is 0. My variables have canceled out. I'm left with a numerical statement, 0 equals 0. Is that a true statement or a false statement? Well, 0 equals 0. So it is true. You can also simplify and use the infinity symbol if you so choose. Makes it a little bit less writing, but I still need to see that you have an understanding that this is a special solution and that it is infinitely many solutions. First equation's in standard form, second equation is in standard form, so the best method would be elimination. Is there anything I can multiply 3 by to equal 5? No. Is there anything I can multiply 5 by to equal 3? No. So we have to find the LCM. 5s are 5, 10, 15, 20. 3s go 3, 6, 9, 12, 15, so on. So notice that there is 15 in both sets. 5 times 3 and 3 times 5. So we're essentially just switching which equation we're multiplying by 3 and 5. Since this 5 is positive and this 3 is negative, I don't have to worry about multiplying by negative because they're already going to be additive inverses. So 3 times 5x would be 15x. 3 times negative 5y would be negative 15y. 3 times 18, 18, 8, 16, 24. 54, so negative 54. 5 times negative 3x would be negative 15x. 5 times 3y would be a positive 15y. And then 5 times 12 would be 60. Combine your like terms. 15 minus 15 is 0. Negative 15 plus 15 is 0. And then negative 54 plus 60 would be a positive 6. My variables are gone. I have nothing to solve for. I'm left with a numerical statement. So is it true or is it false? Does 0 equal 6? Absolutely not. If your friend has $6 and you have $0, you have a different amount of money. So this is false, which means our answer is no solution. All right, go find a couple of examples. You might notice that there are less practice problems and my stand is squeaking on me. So as always, happy mathing.